everybody with this IoT track, and in this case on scalable full stack development at the edge. My name is Pascal Wolkotte. I'm one of the architects within Quby. Quby is a company located here in Amsterdam, for those who don't know us. And we are most known by the product we are actually developing and deploying both in the Netherlands as well as elsewhere in Europe. And that's called Toon. For those that don't know Toon yet, I do a short introduction. Toon started in 2012. The company Quby started earlier already, but it's a combination of a home control box, which is on the left, and what we also started in 2012 is an energy meter, where we gave users insight into their energy use in their home. And we combined them in 2012 into one product. And that's on the right you see, that's Toon. And Toon, because we wanted to provide energy insight and control in the home. And the easiest way to do that in a Dutch home is via thermostat. Because in a Dutch home, everybody almost has a thermostat in their living room. So that's why we created a small thermostat, which also give energy insight and could control your home. So how did we get there? Because we wanted to provide energy insight, we had to be operable with several energy meters, both analog and digital. And there were even more, and this is only in the Netherlands. So also in where we are now in Belgium and Spain, you have different meters. So in every country, we had to interface with different meters. Then in a fast forward to today, is what we currently provide is still the same display in the user's home, but now also with a mobile app. And in the display, you can just control your home and control your heating thermostat, and you can see your energy usage of last day, last month, last year, and you can use that insight to optimize your energy usage in your home. And what we also provide is an app where you can control your house remotely. So I can control now with my app my home if I would like to. And what you also can do is on the app, in the mobile phone, you can, what we call now have a waste checker application, where we look in your energy data and we find appliances in your energy usage, and we indicate if that appliance is either efficient or not efficient. And if it's not efficient, we give you suggestions how to become more efficient. So what we do, yes, we provide an IoT platform, namely display and some other sensors in the home, but we actually use that platform to deliver services. So we provide comfort control via the smart thermostat. We provide energy insight, as you saw in the previous slide. We control lighting. So for example, you can control your U-lights in your home. And we have other services to come. So how does this IoT platform look like? I will shortly go through the platform and what we install in the home, and just to give you an overview of all the software we develop at the edge. So on the top, you see all the different inputs of the system. So you have, for example, your solar panels, your electricity meters, and your boiler in your home. And they're all connected via one or two modules that either measure the energy reported by the energy meters, or it's controlling your boiler or your heating system. And all these nodes in your home are connected either via wire or wirelessly to a display. And that's our central Toon product everybody is familiar with. That's what you see in commercials. That's what you see in posters. You see our display. That's the home part. And in the home, we can also connect to other IoT devices. For example, Philips Hue lights, smoke detectors, or smart plugs. And for example, smart plugs give you both control of your appliances connected to the smart plugs as well as energy insight. But more importantly, the display is connected to a cloud infrastructure. And it's depicted here small compared to the display. But if you compare it to a single display, it's a little bit bigger than in this picture. And via this cloud infrastructure, we're also able to connect the mobile to a display. In addition to the mobile and a display, we also ensure that people can get proper support. So it's not only that you get a display and a mobile app. If you have problems, there is a way to call a help desk, and we are able to do remote support and help the user. And we do that via a support portal, which in the end can connect to the display. And in addition to that, we have offline support for end users, and we also do all kinds of usability tests. So coming now to why do we need to be scalable? Because this was only one display, but to give you an insight, we roughly install 10,000 or more devices each month in different homes, and that scales exponentially. So each time our platform scales, and it scales continuously. So, and if you look to our company, Quby, it has 150 employees and only 70 DevOps. So although our platform scales, our organization doesn't. So we have to be clever and smart on what we do on a daily basis to maintain our platform and to actually develop the new services on our platform. This is Codemotion. I would like to give you an insight on, I called my talk full stack, how many stacks we have in our platform. So speaking from the modules connected to your meter and your boiler, that's just bare metal and C. Then in our display, it's running a Linux environment with Qt UI. So we program there in C, C++, and Qt. And we use some Python in the end-to-end testing. For our mobile phone, we deploy both on Android and iOS, and we use a hybrid approach for that. And in our service infrastructure, it's fully Dockerized, and the main programming language there is Java. And in addition to that, we operate that cloud infrastructure as well. We use that on a Mesos Marathon environment, which is mainly controlled by a Python script. And we have a big data infrastructure where we do all the, for example, for spilling check computations to really find appliances in your energy usage. And we use there Python and Scala. And to tie this all together, because this we have to release on a regular basis, we do CI/CD using Groovy and Python scripts, and we have several APIs amongst the OpenAPI, which you can use yourself to, as a third party, to develop applications and to connect to your own Toon. So then, which full stacks are we considering? So we started with a full stack from mobile to display, and that was primarily just a point-to-point connection, and for support, from the support portal to the display as well. Then, because big data become more important, for us it was key to log all the big data, which initially was stored on the display itself, to transport that also to our big data farm, which we have a continuously a 10-second interval. Each house is reporting data to our big data farm. So it's a huge stream of data which you have to analyze. And then based on this big data, we provide services for the end user, and we report this both on the mobile app, as you've seen with the spilling checker, or on the display. So what are our main constraints, looking at all these full stacks? I think we have two. One on the IoT side, and one on the cloud side. On the IoT side, we are severely resource constrained. So we are not able to deeply cool our display. It's just a display, 400 megahertz, 128 megabytes of RAM. So we have to be careful what we do in people's home. On the other side, on the cloud side, we have a different constraint. Resources are, let's say, in theory, infinite, but our pockets aren't. So we have to be clever on where we spend the money and how we are using our cloud infrastructure most efficiently. And as we are a small company, but I think that accounts for every company, big or small, in the end, we are constrained by people and their brains, and we have to be clever on what we do. So to give you an insight, what we do to deploy our edge, so we are updating the devices in the home. And because we provide new services, we do that on a very regular basis. Currently, we do that monthly, and I will show you a little bit, give you an insight on how frequent and how we do this. So I showed you a picture with only a subset of our devices. And on the left, you see all the devices we currently support, which are displays, several IoT devices, as well as several versions of meter modules and boiler modules, because we have to be compliant with different devices in the home. And we have several customers. So it's not only one device to one customer, so it's all the same. Every customer has a different demand on, for example, how the look and feel of the display is, which devices are supported, etc. So this whole infrastructure is maintained by 12 embedded developers. They control 144 repositories and roughly 500,000 lines of code, which I think it's considerable, because given that a developer can only manage a certain number of lines of codes to be able to maintain, they're really on the edge. And in total, because we're also still using some external third-party library software, in total we manage in the home 1.4 million lines of code. So how do we deploy this on a regular basis? Initially, we did this by hand. And in the beginning days of Quby, we even had to drive to certain homes because an update failed. And that cannot happen now anymore, because we have more than roughly 500,000 devices in the field. So we are not able to, if an update fails, go to every house in the Netherlands and just fix the problem. That's not the way to go anymore. So we started this initiative in 2015. And we're fully focusing on CI/CD to just ensure that quality is right and that we can have a regular pace in our development. This was still all controlled in the house, and but version controlled. What you saw at that time is that developers started committing more and more, but it was still hard to maintain, and it was still running locally in the office. So that doesn't scale. But just to fast forward jump to today, it's now fully cloud-based. So although it's still embedded devices, we're building everything in the cloud. So it's developers working still in the office, not just anywhere in the Netherlands. So we are still located in Amsterdam. But all the build farms is based on Dockers, and they're all built in parallel. So if a developer does a Git commit, several runners are started, the artifacts are stored, and when the artifacts meets the quality criteria, we deploy them to the field. And to just give an impression on how many deployments we do to the field, if you count up all the displays and all the embedded devices we have deployed already, and if we update them on a monthly basis, you come to a stunning figure of 12.5 million deployments each year. Or actually, we deploy every 2.5 seconds, we update a device in the field. So, and the mantra we are mainly using here is we should be able to just develop our software on the moon, and so everything should be in code, such that if somewhere an event hits, we should still be able to continuously update our IoT devices. So what do we still do in the office? We still we visualize all the CI/CD results we visualize in the office. And what you typically see is, because you visualize it, you get the discussion, and people are triggered that we are continuously monitoring our field infrastructure. So I wasn't there in 2014, but Wouter, who's also here in the room, he was. And he actually made a comparison between what happened in 2014 and what's the current state. So in 2014, we did 4 deployments a year. And only 4 because we were just scared that we fucked something up. So we only, to still ensure the quality, we had to do a release cycle of 6 weeks. And even then, we did a field test. We sometimes found low-level bugs in the modules, which could have been solved earlier. And because everybody was too scared to release, really there was somebody in the office to do a signature on that particular release, and the developers just didn't want to release. So what's the current date? Is we release every month, and we try to ramp that up to every 2 weeks so that we can faster and faster incorporate feedback. The total regression time currently takes 4 weeks. So there's a cadence of both the test as well as the release cadence. We hardly find any bugs in the field anymore. We don't need any signature anymore. It's just the developers themselves with their product owner decide this is good enough to release. And they do it with full confidence. And actually, because it's now so automated, they really start innovating. And I will shortly explain how we do this later in this talk. Then something on trusting in the edge. So we also had last year a lot of discussions on how do we ensure that we trust the data we get into our services. Because in the end, we are developing services, so we have to trust the data coming from our edge to our services, and vice versa, that the user gets actually the service he wants. So there's a lot of trust involved. So I'll explain a little bit how we did this in the past. As said earlier, the mobile initially directly connected via a backend service to a display. And the display was installed by an installer, and the display had a certificate on it. And by that, you could trust the display. So the certificate was saying, this is display X, and in our local backend service, we had a lookup from this display belongs to that user. So the trust of the user was in the certificate, and still is, for most of the displays. So the bottom part is fully user, but the display isn't. So then we started adding an OpenAPI. So that API was exposed such that mainly, initially, expert users could control their thermostat via an OpenAPI. And we quickly realized this API is roughly the same as our mobile app. So what we did is we combined the API, and we are currently using both the mobile API as well as our OpenAPI. They're the same. And they connect in our service center, not to one single backend anymore, but to microservices. So each part of the API is forwarded to a particular microservice, and depending on if that microservice needs the display or not, it's routing the messages to the display. But still, at the VPN, the trust of the user goes to the trust of the display. And for us, that's a problem. Because if the display with a trusted certificate, that doesn't scale, because if the display is not updated, so it doesn't get updated software, we are not in control. If the display reaches the resource limitations, we are really out of control. So we have to ensure what I said earlier with resource-constrained system, really be clever. What do we do on the display and what do we do in a microservice? And even a bigger problem is, what if the certificate expires? Because then we're just losing the connection to our display. And keep in mind, these displays we started deploying in 2012, and we're currently still deploying those displays, and we have to support them still for a number of years, because we still want to have the services on our displays available. So what is the step we are making? We just consider the display equally to a mobile or to an OpenAPI. And that was for us a big shift. So what we do is the display talks to the same API as a mobile. And in that sense, it also changes the trust. We can remove the certificate from the display, and we leave it up to the user to trust that particular display, or actually the software on that display, to have the data forwarded to our services. So we put the user in control and not the hardware in control. And what we do still, sure, we still have to manage our devices, but that's a separate problem. So here, this is the trust of the data, and the user trusts the software on one of these devices, to handle the data on his behalf, and then the microservices know which users they are talking to. So what does this bring us? Each device can have multiple roles, because still some of the devices produce data and others consume, or in case of the display, it does both. And here I depicted still devices which have a display, so they can have direct interaction with the user, but also in this flow we support headless devices. And what we in principle now start doing is, because we now have everything on an API, every development of new features starts with contract first. So the developers and the teams work together, and they first work on the API, so then later on they can start working independently and have clear contract how they want to use and offer the service. And if you want to integrate, for example, still the mobile to a display, we use the cloud for that. So we don't have local connection between display and the mobile that goes via the cloud, but it doesn't go to the microservices. So we do some shortcut routes without a microservice, so we can directly route the mobile to the display. And we're using Amazon IoT for this. And if you compare that to Microsoft that released its Azure Sphere lately, where they say we really have to trust the devices, we are taking a different route. We are taking a route where the device is for us not the user. So we are trusting the device for different reasons, but not because it's a user. So how do we then do configuration at the edge? Because now you have software deployed, you have trust, but how do you configure it? Because it's still a different user. So how did we do that in the past? Because we started as a small startup company, which was doing a lot of proof of concept, so a lot of different configurations had to be started. So over time, they developed a system where with some defines, they could just tailor the software to either, for example, a specific type of display and to a specific type of customer. And as you would expect, the architecture would select only the toolchain because you have to cross-compile for a specific processor, but it did way more. And also certain features were compiled in instead of that they were enabled at runtime. So if you then ask the tester, she's still happy here, but actually she wasn't, because she had to test all the different configurations. Oh. She still had to test all the different configurations, and there's where the long release cadence came from. So again, what we had in the past, almost every device had its own executable, either a device, a different customer, a customer group, an environment. For example, production and acceptance was different. Different clouds, so we have a cloud for each tenant. Every cloud had a different instance. And where are we going as of today? We currently already have a single release for all devices, so it's all based on the same code base and also based on the same executable, other than, of course, the processor architecture. So you still, if you have a different processor, you have a different executable. And the devices, they are tailored to a specific customer based on activation. So if a user activates it, if he is, for example, an Eneco customer, it's then tailored to Eneco. And that's a big plus for supply chain, because if now your devices are equal until it reaches the end user, the supply chain becomes significantly easier. And what we do, because still at some point, some customers either have more features ordered or a different demand. So we enable features in the display and in our system based on feature toggles. Currently, that's still a homegrown solution, and we are still looking for an off-the-shelf solution as a service, so that we can really control different parts of our infrastructure in a relatively simple way. So how do we make these steps? As I said earlier, the developers are now really innovating. And what we started doing mid last year is to enable this innovating, we introduced Foggy Friday. And within Quby, that's now a well-known term, but I suppose in this room it isn't. Because we are working on the edge, we phrased it related to fog computing, a Foggy Friday. And what happens on these Foggy Fridays? Because they happen every twice a week. So what we do is a team of developers, they choose an improvement topic. And the criteria is they have to finish it in a day. And when it's finished after that Friday, it's really merged on Monday and rolled out to production. So in principle, it's a one-day improvement. And you could consider this a hackathon, but we do this on a really regular basis, and thereby we make continuously improvements in our way of working. Things what we've, for example, deployed are which services are used frequently, what are resources are used in the IoT edges. We've deployed new prototypes to the field to a subset of users, and it also is great for inter-team features. So for example, if you have multiple feature teams and they really have to nail something in a day, then it's a perfect recipe to do this in this way. And the effect is not only that we have things in production, but we get also more ownership at the developers, and they can really show what's possible in a day. And they, in the end, also have a lot of fun, which I think is also crucial as a developer. And this is our CTO on the left, and it's now frequently that either the board or somebody from the business side says, hey, let's spend a Foggy Friday on this to really show that this concept could work. And another thing what we do is, because we cannot change everything in one day, we don't want to do all kinds of greenfields approaches where you want to change the whole world at once and set up a new system parallel to the existing system. So we apply the strangler pattern. And we do gradually changes to our code base, and after a while, the old system is not there anymore, and it's just replaced by the new system. But it will evolve over time. So they continuously have to live together, and at some point, they're gone. However, this is what we did so far to get a more scalable IoT platform. We're still not there yet, and at the end of the talk, I would like to spend a little bit time on the things we're still looking at. And I'm also open to have discussion with you after this talk on these topics. So currently, as you saw earlier, a lot of our home development is still C, C++ based, and we are looking into other alternatives just to simplify the way of how you enable features. And one of the things we are looking into is Go. Another thing, we are currently have microservices based on Java, but we really see to move that into, instead of microservices, go serverless and do function as a service. And how we have to do function as a service and which language, that's still something we are looking into. Another thing, a topic which we haven't still solved, is really use the power of all the IoT devices. Currently, our big data crunching and the data algorithms that do smart things, those are deployed in a big data cluster. And we do some small parts in a display, for example, controlling your heating in your house. But all these locations of these algorithms are historically determined. So it's either a developer that was available at that point in time on that particular part of the system. And in the end, what we want to do is really use the power of our IoT devices in combination with the flexibility of our cloud environment, and thereby migrating some of the algorithms from one side to another or back without doing a full re-implementation. So ideally, you describe the algorithm once, and based on the criteria of today, money, resources, whatever, you deploy the algorithm where you want. How we have to do that, we still have to find out. And what's an end device? For us, currently, it's mostly a consumer of the services or producing of energy data. But what can it be more? Can it be storage? Can it be? We have to see. Questions?
Hello, can you hear me?
Yes.
Wonderful.
Can you hear?
So your Foggy Fridays thing, if I may just focus on that for a very quick second, it has to be done in one day and it's shipped on the Monday. What if, despite the best intentions and attempts of the team, it's not finished by Friday? What happens to that improvement? Do they not bother shipping it, or do they move over to a second one? How does that work?
Most of the time it goes to the second one. So basically we then strip it down to what can we really finish in one day and make more smaller pieces. But if you really, for some reason or another, you haven't identified the risk properly or whatsoever, we spend another Froggy Friday on this. Other questions?
If you've seen ownership take a huge leap when developers choose their own innovations to work on, why do you restrain it to once every 2 weeks?
Very good question. That's what you get also internally. So why don't we have 10 Foggy Fridays every sprint? And yes, that would be ideal, but we're not there yet. But that's something we have to figure out, because ideally you would have these Foggy Fridays every day.
Yeah, just a small question, more aiming at the devices that you connect to in a household.
Yeah.
Are those developed as well by Quby, or is it third-party devices?
Both. So the meter modules connect to the energy meters is both. We developed initially everything in-house for the Dutch household, but when we got to Belgium, we realized we cannot do it all ourselves. So we developed one with a partner. And what we're aiming more and more for is that we integrate devices made by others. Because if we have to do it all ourselves, it doesn't scale. So basically what we aim for is what we really cannot find in the market, we do ourselves. But ideally, we just integrate with everything that's out there.
So do you still have a strong hardware component in your company that still also creates hardware, or is that all?
Compared to the number of DevOps, hardly any. So it's mainly software and only a few hardware engineers that really look into the real detail hardware problems and designs, and the real hardware design of the components themselves, we already outsource.
So you support all these kinds of transports like Zigbee and Wi-Fi, or how do you connect to the smart display?
Yeah, so in our current display, we support Z-Wave and Wi-Fi. So the internet connection goes via Wi-Fi, and the connection to the meter module is going via Z-Wave. But we have to extend that to other wireless endpoints as well. So for example, Zigbee, Bluetooth, and maybe others.
Thank you.
Considering the 25th of May is coming up,
Yep.
and you do some computing on household data.
Yep.
Have you guys? What is your stance on the privacy concerns that you obviously have when there's a lot of household data coming into your data stores and that kind of stuff?
Yeah. So basically, the data we get from end users, we do that with their consent. So every individual display has the ability to stop the stream from the house to our data farm. So the user is, in that sense, full control of if he is able to give the data to us or not. And then we store it anonymously. So we still don't know that it is your data.
Okay.
And then once we start processing, for example, for the spilling check, the user gives us the option to do processing on his behalf, and then we give them the results back based on our smart algorithms.
Okay, cool.
Considering the hardware is one of your major constraints in the development, how do you reconcile the lack of hardware engineering as opposed to the level of software engineering you do? Do you see that as a big influence going forward?
No, actually not. It's strange. As I said earlier in my talk, we are providing services and we use the platform to deliver the services. But what we see more and more is by partnering with others that make devices and can do that more and better because they do it frequently than we. It's for us easier to partner with somebody else creating the hardware or integrating on a certain standard, for example, Z-Wave or Zigbee or another open standard, and then integrating on that level.
And how does that combine with the screen that you want to put in your house, the major marketing effort that you have, so to say?
Yeah, so the screen is, the tone screen as showed earlier, is actually, or was developed by ProDrive at the time, and we partnered with ProDrive to do production and do full optimization on that screen. So that's just a partnering with a partner that's able to do the job very well. There was a question in the back.
Hi. Have you considered storing all the user data on the devices themselves, so that you don't have to store them in your backend system?
Yes, we did. Initially, we actually didn't store it in the cloud. We only stored it on the display. And for some cases, that works perfectly if you're really using the display in a house environment and you don't want to run smart algorithms on it. When you really have to do smart algorithms and want to do batch-wise and don't want to develop it all on a severely constrained display, then there's no way out than moving it to the cloud. At some point, the algorithms become simple again, and then we can migrate them back to the fog. So, but at the end, the display is also storage-wise constrained, and you're not able to store 10 seconds or even when it's going to 1 second data, you're not able to store that on a resource-constrained device. Not for a long period, maybe for 1 or 2 days, but at some point, the storage problem will hit you. Other questions? Then thank you for your attendance.